This is Earthfiles, the award-winning news site with the latest updates in science, environment, and real X-Files. Podcasting in-depth reports beyond the 6 o'clock news by Emmy Award-winning journalist Linda Moulton Howe.
On the first day of December 2009, Phil Jones, Ph.D., Director of the Climatic Research Unit and Professor in the School of Environmental Sciences at the University of East Anglia in Norwich, England, stepped down pending an independent university investigation of alleged academic malfeasance discovered in leaked emails. The allegation is that Dr. Jones used the words, quote, "a trick to hide the decline," close quote, in a chart detailing a recent plateau of Earth's global temperatures in email correspondence with several of his research colleagues, including Michael Mann at Penn State in Pennsylvania and at the National Center for Atmospheric Research, known as NCAR in Boulder, Colorado. Dr. Jones' emails are among thousands of pieces of correspondence between various scientists about global climate data. Dr. Jones argues he used the word trick to mean, quote, "a clever thing to do," close quote, in analyzing data. Further embarrassing leaked emails include how to keep scientific work that is critical of a global warming trend out of peer-reviewed journals. On December 3, 2009, Professor Emeritus Geophysicist Henry Pollack, Ph.D., and 2007 Nobel Peace Prize participant, was in Albuquerque to speak at the University of New Mexico about his new book, A World Without Ice, released in October 2009. I was able to interview him before his presentation about the recently leaked climate emails scandal, the December 2009 Copenhagen Global Climate Conference that Dr. Pollack will attend, and his perspective on Earth's climate, past, present, and future. According to the United Nations Intergovernmental Panel on Climate Change, Earth will warm up between 1.4 degrees Celsius and 5.8 degrees Celsius by the end of this century. That's roughly a 2 degrees Fahrenheit to 10 degrees Fahrenheit rise. I asked Professor Pollack what impact he thought the leaked climate email scandal would have on the December 2009 climate talks in Copenhagen.
The University of East Anglia has been a climate data center and a center of climate research for most of a century. It's one of the better-known climate research units in academia around the world. But they're not the only ones that do similar types of research on constructing the temperature changes over the globe over the past century, from weather station records and temperature sensors in buoys that float around the ocean and such. And the same type of work is done by NASA in the USA, by the National Oceanographic and Atmospheric Administration in the USA, by the British National Meteorological Service, called the Hadley Center in the United Kingdom, by other institutions in Germany and Japan. They do it independently. They all use more or less the same data, and they all make their own decisions as to which data are reliable and which are less reliable. They all make their own decisions on how to make corrections to readings for changes of thermometers over the years and such. But this research goes on independently at many different places. And so the important result of comparing these independent exercises of constructing the temperature history of Earth over the past century is that all of the reconstructions, all of the assemblies of data, tell the very same story. And so even if the University of East Anglia had been doctoring or fudging or manipulating data, mind you, I am not accusing them of that, but even if they had and the entire research output were discarded, there would still be the same result from half a dozen other institutions done independently by independent scientists making their own scientific judgments. So I don't think that it should have a big effect at all because the data itself is so persuasive that you cannot erase climate change from the record, nor can you put it in. This is nature speaking, and it is a story that the 20th century has been one of warming over the long term. Now, the predictions of the climate scientists in projecting future temperatures, they don't predict that there will be an incremental change year by year. They are saying that there is a long-term trend upward, but the natural variability of Earth's temperature due to changes in ocean currents, the El Nino events, the Arctic oscillation of the ocean waters, there's a lot of phenomena like that. It superposes ups and downs on the long-term upward trend. And so climate scientists do not say that every year you're going to see an increase. Some years we know there are even decreases, but over the last year, the temperatures have kind of plateaued at a very high temperature. The temperatures over the last decade, although they have not been climbing year by year, they still are the hottest decade in the entire instrumental record. And so it's not as if the Earth has suddenly started to cool. It has plateaued for a decade or so in its upward climb. But that kind of pausing or ups and downs that we see on shorter timescales, that's not climate. We're looking at climate as the long-term trend. And to any eye that looks at a century worth of data, the trend is upward, and there's nothing in the last decade that will negate that. So my assessment of what has come out of the East Anglia situation, my personal assessment is that it's a tempest in the teapot from a science point of view. It does not undermine the global data set. It does not undermine the fact that the Earth is warming. It may say something about a particular group of scientists, but they are far from representing the whole scientific community. And so I just don't make that much of it.
In your perspective, do you think that CO2 buildup is as important as water vapor?
CO2 is a greenhouse gas, and water vapor is also a greenhouse gas. And the two actually are interlinked, because if the atmosphere were to warm from the greenhouse effect of carbon dioxide, it would be able to hold more water vapor. A warmer atmosphere can have more water vapor. And so there is an increase in evaporation, and more water vapor joins the atmosphere as well. With that amplification of now having two greenhouse gases instead of one, it simply is getting warmer faster. I don't think it's a trade-off of one or the other, or that one has been ignored. All the climate models that I know of recognize the fact that water vapor will grow in the atmosphere as the atmosphere warms.
Is there any reason why water vapor has been excluded from the discussions in Copenhagen?
I think that the so-called exclusion is not simply of water vapor. The exclusions are broader in the sense that they're dealing with water in every setting. It's not just vapor in the atmosphere, but it's the entire hydrological cycle and the environmental signatures in different parts of the globe of the consequences of climate change on the hydrological cycle. And that is what has been set aside as a discussion in Copenhagen, because Copenhagen is dealing principally with ways to mitigate or slow down climate change, and the perturbations to the hydrological cycle are some of the consequences of climate change. And in choosing to focus on the causes as opposed to the consequences, that has been the conscious choice of the Copenhagen delegations to focus strongly on causes of climate change and their mitigation. And it's not to say that the consequences and the impacts on the hydrological cycle are not important. It's just that that's not the focus of this particular conference.
And using the title of your new book, A World Without Ice, can you describe what you see happening and why you think we're headed for a world without ice?
Well, ice is a very sensitive indicator of climate change because it is very close to its melting point over large regions of the Earth. And so with very small changes of temperature, you'll see big changes in the distribution of ice. And I like ice in that context because I call it nature's best thermometer. It doesn't read the newspapers. It doesn't listen to debates. It has no ideological baggage. When it gets warm enough, it melts. And so it's a natural thermometer, and it is talking to us. Places that are more accessible to most people are mountaintops, such as the high mountains of the Himalayas or the Andes in South America, or even in Glacier National Park in the USA. The ice in those high regions at mid-latitudes and tropical latitudes is receding in the valleys and thinning the thickness of the ice very dramatically. And if that continues over another few decades, we'll see the loss of most mountain ice by mid-century. And the consequences of that are very significant because the meltwater provides the agricultural water. About a quarter of Earth's population are drawing their waters in part from the high ice in the Himalaya. And so losing that ice has a big impact on large numbers of people. The second component of ice that is changing is the Arctic sea ice. Usually the Arctic Ocean freezes. In fact, throughout human history, the Arctic Ocean has been largely frozen over. But every summer, it tends to break up a little bit, and then it refreezes again in the winter. And so it's basically been a big frozen sheet of seawater. And in the last few decades, more and more of that has been breaking up in the summertime and exposing the dark ocean water, which absorbs the sunshine, and therefore the ocean gets warmer. And therefore, it's harder to freeze it again in the fall, and it doesn't freeze as thick over the winter, and it begins to break up earlier in the spring. And it's a feedback cycle that is quickly destroying the sea ice in the summertime in the Arctic Ocean. And if the rate of loss of summertime sea ice continues, we'll see an ice-free Arctic Ocean by mid-century as well, with big consequences for the territory around the Arctic Ocean, the largely frozen areas of northern Alaska, northern Canada, and Siberia, where the permafrost is beginning to melt. It will also open up international tensions in the Arctic as people vie for the fisheries resources. There will certainly be exploration for oil and gas. There will be increased commerce through the Northwest and Northeast Passage, the shortcut to Asia from Europe and North America. And so we'll see the Arctic Ocean turning into a beehive of activity when effectively it's been off limits to human activity for as long as humans have been on Earth. One climate scientist I know has said that an ice-free Arctic Ocean in the summer will be the biggest change in Earth's landscape that people have ever seen. A third effect is the creeping melting of Greenland and West Antarctica, where there are big piles of ice sitting on those pieces of land. And summertime melting in Greenland is creeping higher and higher onto the Greenland ice sheet. And the meltwater is running into crevasses and plunging deep down to the base of the ice sheet and lubricating the bottom of the ice. And the consequence of that is that glaciers that are shipping ice off of Greenland to the sea are now moving faster and delivering their ice more rapidly. And so Greenland is actually losing ice mass every year at an ever faster pace, as well as West Antarctica experiencing the same thing. And so we're seeing what I call a sleeping giant being awakened. Ice that has been with us for most of human history is now being destabilized and being returned to the sea. And ultimately, the consequences will result in rising sea level as well, because every time you send meltwater back to the sea, you add to the seawater. But even just dropping ice into the sea, it raises sea level right away, just like an ice cube in a beverage glass does. So we're seeing a lot of action in the cryosphere, the world of ice, that shows it's responding to climate change in ways that have big impact on the human population everywhere around the globe.
And continues to melt regardless of human arguments.
Indeed, nature is talking to us. If we don't listen, we're doing so at our own peril. The effects of rising sea level, the effects of changes in our hydrological cycle, greater rainfall in some places, greater desiccation of the soil in others. Nature is sending us a strong message, and if we don't pay attention to it, it will be to our adverse consequence.
How long do you think it would be before the Arctic is ice-free most of the year?
I think by mid-century, at the rate we're going, the Arctic Ocean will be ice-free in the summertime. It will, of course, refreeze in the winter, but it will be a much thinner ice sheet and much more vulnerable to summertime breakup. So I think we'll see ice-free summers in the Arctic Ocean within the first half of this century. We'll see the loss of the mountain ice probably even sooner over many of the low-latitude or tropical glaciers. The destabilization of Greenland and West Antarctica is a longer-term process, but we could actually see enough ice lost from those two areas to have a sea level change by the end of the 21st century by as much as 6 feet. And in the very long term, if we lose all the ice from Antarctica and from Greenland, and I'm not predicting that in any immediate future, but on a millennial timescale, that if we lose all of that ice, sea level will rise by perhaps as much as 250 feet.
Which would flood most everywhere.
Most everywhere. Even thinking of much more modest sea level changes in the 21st century, which are probably going to be in the range of 3 to 6 feet. A 3-foot rise in sea level will displace 100 million people around the globe. That's how many people live very near the seashore, within just 3 feet above sea level. It includes people who live on atolls in the Pacific. It includes people on the Maldive Islands in the Indian Ocean. It includes people who live in the major low-lying deltas of the Ganges and the Nile. So we're going to see large-scale displacements of human population of a scale that humanity has never dealt with before. And there will be great political and social instability occurring and amplifying year by year for every year that slips by without people beginning to address this issue.
When was the last time period that the Arctic was completely open?
I think that the last time period that we can be certain the Arctic being open was probably 55 million years ago, when the Earth probably had no ice at all. That was perhaps the last time that we were totally ice-free. But there was a period of time only 3 million years ago when sea levels were about 100 feet higher. And that might have been a time when Greenland had lost its ice and Antarctica had lost some of its ice. So only 3 million years ago, with sea levels 100 feet higher, that shows you the magnitude of change that can occur effectively in the context of the modern climate system.
Is it true that scientists really don't understand the mechanism for why the Earth goes in and out of icy periods and no icy periods?
We know that the last time that the Earth was totally without ice, 55 million years ago, that there was a large exhalation of methane from the ocean floor. There's a lot of methane stored beneath the ocean floor. And for some reason, that was destabilized. And methane is a powerful greenhouse gas, and it went into the atmosphere and raised temperatures significantly for a fairly long period of time compared to human history. And the consequence was that Earth warmed up and lost its ice.
Do you have a hypothesis about what would have released so much methane 55 million years ago?
My hunch is that all you have to do is raise the temperature of the deep ocean water a few degrees, and you can destabilize it. So it may well be that in some parts of the globe, there was a situation of ocean currents and the like that maybe led to a warming of the deep ocean and a release of some methane locally. But once that reaches the atmosphere, then it becomes a global greenhouse blanket, and it warms the sea everywhere else, and you destabilize some more. And so it's kind of like a runaway process that led to large-scale loss of methane from the ocean floor.
Well, Professor Pollack, if that happened 55 million years ago, and a combination of industry and other factors are now increasing general average global warming, then what are the chances that we could have a huge methane release from the oceans sometime this century because the ocean water is warming?
But that's a good question. Currently, we have a lot of measurements of temperature down through the ocean column, and the water is warming, but the warming so far has been confined to about the upper 2 miles, and it hasn't penetrated to the deepest ocean levels. And so it's going to take some time to warm that body of water mass. I don't think that warming can take place in this century, but an uncontrolled greenhouse and the growth of global temperatures, that will eventually penetrate into the deep ocean water, and it conceivably could destabilize the methane in the ocean floor.
What is the depth of our deepest oceans?
Well, the average depth of the ocean is about 2.5 miles. We've seen warming measured down to about 1.5 right now.
That has occurred in what time frame?
Well, we don't know how long it has taken to warm up because we've only been measuring ocean temperatures over large areas and to great depths for maybe half a century. So we can see the warming has taken place, but we can only, through model calculations, estimate what processes were active and how long it takes to mix the ocean from the warming that takes place at the surface to circulating that heat down to greater depths. So it's a little hard to tell, but the processes have not distributed the heat to the deep ocean bottom in any great amount, at least as yet. But the last time when the sea level was up by about 100 feet, only 3 million years ago, it's not quite so clear what caused that, but it shows you the range of possibility of global climate system in a world very much like we know today. Now, the issue of what causes ice ages coming and going in rhythmic or periodic pattern, we understand kind of the pacemaker of that. It has to do with the orbit of the Earth around the sun and the orientation of the Earth towards the sun. There are 3 factors that are important. One is the shape of the Earth's orbit about the sun. It is elliptical, but the ellipse sometimes gets more elongate, more like a cigar, and sometimes much less so, more like a circle. And that effect determines how uniformly over a year the sunshine that reaches the Earth warms the Earth. If you come very close and then very far from the Earth in a yearly excursion around, then the distance effect means you get much less sunshine. So there's an amplification of the seasons due to that changing orbital shape. And that shape changes with a period of about 100,000 years. The tilt of the Earth's axis currently is about 23.5 degrees, but that oscillates between 21 and 24 degrees with a period of a little over 40,000 years. And the more the Earth is tilted, the more seasonal variability there is. And so you again see the effect on the seasons. And then the third effect is the orientation of Earth's rotational axis. It goes about in a big precessional circle, kind of like a spinning top, will slowly wobble. And that determines whether the elliptical effect and tilt effect reinforce each other or work against each other in one hemisphere or the other. The summary of all of that is that these orbital effects with tens of thousands of years of periods create effects where it promotes a lot of snowfall at high latitudes, and that's the start of an ice age. The effects themselves have to be amplified in other ways, which there's still some puzzlement about, but it's clear from the timing of the ice ages that these orbital effects are the pacemaker or the chronometer of glaciations of the recent past.
How much impact could the sun have?
Well, the sun is a big player, of course, in what I just described, because the orientation of the Earth and the distance of the Earth from the sun determines how sunshine falls on the face of the Earth. Now, in terms of shorter-term climate change, there are variations of energy from the sun that occur on all time scales, from daily to monthly to yearly to even longer periods. But in examining those variabilities in the context of the current warming of the Earth, the measurement of the radiation from the sun indicates that it's actually been under slight decline in the last half of the 20th century. And if that were the only factor playing a role, Earth would have cooled slightly. But in fact, Earth warmed dramatically, so we know that there are other factors besides the sun.
From your perspective in writing the book, A World Without Ice, what is the worst case as we move forward in this century and beyond of a planet that does continue to warm and ice continues to melt?
Well, the worst case, of course, the global consequence is rising sea level. It'll have many effects that are different from place to place, but rising sea level is a major consequence that will have the biggest social and political consequences because it will displace hundreds of millions of people. And so, from my point of view, sea level rise is the global hazard at the top of the list. My own guess as to what we'll see in this century is anywhere from 3 to 6 feet.
And is one of the ironies as ice melts and ice is changing to water, that a consequence of the future could be that there is more drought, even with all the melting water?
Well, that's true. You'll have an acceleration of the hydrological cycle, which means that we evaporate more water from the surface of the oceans and the continents. And so you'll see soil moisture loss expressed as drought. But you'll also have more intense rainfall as that moisture is reprecipitated elsewhere. And so you'll have both intense droughts and intense precipitation events, tremendous bursts of rainfall in short periods of time. So it's acceleration of the hydrological cycle that will have these regional extreme perturbations.
More drought in some places and more water in others.
Yes.
Now, in Copenhagen, are you expecting that there will be any discussion about governments around the world having any planning or mechanisms now for handling what appears to be the huge challenge of what do you do when island nations go underwater, and then what do you do as larger nations also have water coming up on their shores over this century?
I think that will always be in the background because it's a major consequence. But the principal focus of the discussions and debates in Copenhagen is how to slow the greenhouse blanket from getting even more efficient, more effective, thicker, better at trapping Earth's heat. That's what needs to be slowed down and reversed. And that's the central focus of the Copenhagen conference.
What do you personally think would be the fastest and most efficient way to get a handle on controlling CO2 emissions?
There is no silver bullet. The lowest hanging fruit is simply using less energy. It's conservation and efficiency methods. The cost of that energy is effectively zero. If you don't use it, you don't pay for it, and it's not produced.
If China and India don't go along with that as a goal, what do you think the consequences practically are over the next decades?
China and India are still burning coal, as is the USA. But the country that learns how to break away from coal and petroleum and utilize renewable energy is going to be the leading industrial economy of the 21st century. And you can be certain that China wants that to be in China. They are already leading the way in wind energy. Europe is leading also in wind energy. The USA is lagging. And all of the big energy consumers want to be the industrial leaders that lead us out of the carbon-based age. And so we're going to see a lot of competition, not to see who's going to burn more coal. There'll be competition to see who leads the industrial revolution of the 21st century that will take us into a new energy environment.
When you think about where the future of this Earth is headed, and you've written a book called A World Without Ice, what is your greatest worry about where we are all headed?
My greatest worry is that people don't recognize the urgency of what needs to be done. There's little question in my mind that the rising sea levels and climate change are going to catch people's attention sooner or later. But we need to have it be sooner. So my biggest worry is the slowness of the developing awareness that this is a real problem and it has very severe consequences. I'd like to see things being addressed right away, and I worry that there'll only be baby steps taken and a wait-and-see attitude. That will lead to situations that grow out of control and will not be able to mitigate.
Already no one is expecting anything productive out of Copenhagen.
Well, I'm expecting something productive out of Copenhagen. I'm expecting that the broad framework will be established and that the details of a new climate treaty will be worked out probably in the next 6 months. While the original hope was that the Copenhagen would actually write the treaty, that's not going to happen. But I don't think that it will be an unproductive gathering.
Thanks for listening to this Earthfiles podcast from the edges of science, environment, and real X-Files. Go to www.earthfiles.com to see more than 1,000 Earthfiles reports with photographs, drawings, and documents. And visit Earthfiles every day, every week, for new reports and new podcasts. That's www.earthfiles.com.